Now what we're going to talk about. We're going to talk about a type of compound called a hydrate. Now what we're talking about when we talk about hydrates, okay, it's kind of what it sounds like. It sounds like there's some water involved, right? So that's what a hydrate is. What a hydrate is it's an ionic compound with some number of water molecules that are chemically attached to it. Okay? Now, this is not just something dissolved in water. This is where water is actually part of the chemical formula. What happens is the water gets trapped during the crystallization process, and it actually is attracted to the ions and attached to those ions. So it's part of the compound. It's part of the chemical formula, which means you need to indicate it when you're writing a chemical formula. Okay? And the way that it's indicated is you write your chemical formula, your ionic compound, and then you put a dot, and then you put the number of water molecules, okay, such as you see right here. All right, you see you got your calcium chloride ionic compound with a dot and then 2 H2O. That tells you that there are 2 water molecules trapped in each unit of that calcium chloride. Okay, now why a dot? Because that looks like we're multiplying. We're not really multiplying, but the thing is, you can't use a plus because in a chemical formula, when you see plus, you start a new compound when you're looking at a chemical equation. So we can't really use a plus, all right? So we use a dot. It's not really multiplying, but it's kind of like that because it's part of the chemical formula. It's not something totally different, okay? Now, I want to take a look at something here. Notice, here we have anhydrous, or cobalt-2 chloride without water in it. Okay? Here we have cobalt-2 chloride with 6 waters in it. We have hydrated cobalt-2 chloride. Notice, there's a big difference there. There's a color change. And what do we know when there is a color change? A very significant color change like that. Well, there's something chemically different, right? It's not just a physical change at that point. There's something chemically happening that causes that color to change. That's one way that we know that hydrates, the water of hydration is part of the chemical formula. Okay, you have changed the chemical formula of that compound. Okay? All right. What I want to talk about now is how to name and write formulas of hydrates. Okay, now, if you can do type 1 and 2 compounds, you got this. All right, so to name a hydrate, you're just going to name that ionic compound, whether it's type 1, type 2, name it however it's named. All right, and then you're going to put that dot, and then you're going to have a prefix indicating how many waters there are. Okay? Let's walk through a few examples. FeNO3 3. First thing you got to do is you got to name your ionic compound. Okay, notice Fe, this is a type 2 ionic compound. Okay, so we have to find the charge on that Fe. It needs a Roman numeral, right? So we got 1 Fe. We have 3 nitrates, which has a -1 charge, and that equals 0. So X minus 3 equals 0. So the charge on that iron is 3. So it's iron 3 nitrate. Okay, but then we've got these 9 water molecules chemically attached to it. Notice that dot right there. Okay, so this is a hydrate. So what we need to do is indicate how many water molecules are present. Okay, so we need a prefix that means 9. You might remember the prefix that means 9? It is nana. Okay, so nana hydrate. So the name of that entire compound is iron 3 nitrate nana hydrate. Okay, because there are 9 water molecules chemically attached to that iron 3 nitrate substance. All right, let's look at another one. MgSO4 and 7H2O. Mg, type 1 cation, so magnesium sulfate. And then 7 is hepta. So magnesium sulfate heptahydrate is the name of that compound. All right. And then last one, Na plus, type 1 compound again, sodium carbonate, and 1 water, and so it's sodium carbonate monohydrate. Okay? If you can do type 1 and 2, all you're doing is tacking on that hydrate onto the end of it and however many hydrates there are. Okay? Formula is exactly the same. Okay? So cobalt 2 chloride hexahydrate. All right, well, cobalt 2 chloride, cobalt 2 plus, because that Roman numeral 2, all right? Chloride, Cl minus. Oh, switch them. So you got CO, Cl2, and then it's a hydrate, so we need a dot. And how many waters are there? Hexa is 6. So 6 H2O. Cobalt 2 chloride hexahydrate. Zinc nitrate. Now, zinc's a transition metal, but remember, zinc is one of those exceptions that is always the same charge, right? So, zinc is 2 plus, nitrate, NO3 minus. So our formula there is Zn, NO3 in parentheses 2, and then tetrahydrate. So we've got 4 H2O. All right? So, again, if you can do type 1 and 2, you're just tacking on an ending to it. Okay? All right. So that's all of the types of compounds that we're going to do. Now we just have to practice. You've heard me say that a lot, haven't you? Practice, 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 and then practice.